Hey guys, hoping all is well with everyone. So in this video we're going to be continuing on with our discussion of lesson 1.5. So in our introduction with lesson 1.5 we were introduced to the topic of dividing fractions by fractions, and we saw that in the irony of the situation, the solution to this topic is to multiply by what is known as the reciprocal of the divisor, or the second fraction, or the fraction in the denominator, based on the orientation or the structure of your division, whether it be two fractions over each other or left to the right, so to speak. So in this continuation, we're going to be looking at another story problem, but we're going to kind of see another visual way that shows us when we divide fractions, we're basically taking two steps to split the object or the scenario into the appropriate fractions needed. So when we divide fractions, it's like we're taking one fraction and we're splitting it into multiple pieces. Okay, so the big essential question for this example 1 here is, how can you divide a fraction by a fraction? Use an area model to divide fractions. So the question at hand says that Simon buys 1/2 yard of material to make foot bags. How many foot bags can Simon make? Find 1/2 divided by 1/6. So it says that Simon uses 1/6 of a yard of material for each foot bag that he makes. So the question of modeling with math is, how can you use an area model to represent the division? So in step 1, as I mentioned, this is kind of like taking a fraction of something and then dividing that fraction into multiple pieces. It sounds kind of puzzling, but let's look at it. So step 1, draw an area model to show the dividend. So the dividend is the number that's being divided, 1/2. Now here what they did was they took that 1 yard of material and they split it into 2, or 1/2 pieces. But what I'm going to do here is I'm going to still show you that this whole thing is 1 yard of material, just to kind of keep things organized and for housekeeping purposes. So give my 1 a hat. There we go. Alright, so that's 1 yard of material. So now that we have split the material into 1/2, what we want to do is we want to split that 1/2 of a yard into 1/6 pieces. The way that we're going to do that before we jump into the next step is, if my question is how many 1/6 are in 1/2, it doesn't do me much good to just have 1 yard. I want to represent it in a way that I can use it as a visual of how many sixths are in 1 yard. Well, if I divide 6 into 1/6 yards, that's going to give me 6 equal pieces. So that's what step 2 shows us. It basically took that 1/2 yard and split it into 1/6 parts. But the way that you would do that before you jumped into step 2 is go ahead and split the whole yard into 6 equal parts. I know these aren't exactly the prettiest divisions, but again, just to show you, this would be 1/6, this would be 1/6, and this would be 1/6, and the rest would be as well. But the question at hand is, how many 1/6 are in that 1/2? So if we take that 1/2 yard and divide it into 1/6 parts, there are 3 1/6 parts in that 1/2. So that's what that resultant is showing us. Or then it's saying that the 1/2 divided by 1/6 is equal to 3. But before we jump into that, I want to go over another practice of the division. So remember, if we have 1/2 divided by 1/6, this is going to be equal to 1/2 times the reciprocal of the second fraction. So this is going to be equal to 1/2 times 6/1. This is going to be equal to 6, it's 1 times 6 is 6, 2 times 1 is 2, 6/2, which is equal to 3. Now, if you were to see it kind of in the different format that we kind of looked at last time, if we had 1/2 divided by 1/6, this is again our complex fraction kind of form. We're still going to do the same thing, but again, we're kind of using that multiplicative identity of 1. It sounds complex, but for lack of a better pun. But what we're doing is we're multiplying the top and the bottom by the same number, or multiplying the fraction by 1, which again doesn't change the value of it. It just changes the physical representation and numbers that we're looking at with it. So we have, 1/2 times 1/6, or 1/2 times 6/1 is equal to 6/2 over 1 times 6 is 6, 6 times 1 is 6, and again, even though this looks like a complex fraction, we're going to clean it up right now. So 6 divided by 2 is 3, and 6/6 is 1, so 3 divided by 1 is 3. So that's kind of another way that we can see how we got to that answer. Okay. So this next one is a try it. So it says use the number line below to represent 1/6 times 3 is equal to 1/2. Then write an equivalent division sentence. So what we're going to do here is, if this is a yard, so to speak, kind of very similar to our story problem above, what I'm going to first do is I'm going to break this into 1/6 parts. And the reason for that is it doesn't do me much good if I have one whole of something, because I need to break it up into 6 to visualize a 1/6 measure, because I'm going to be multiplying it by a certain amount, being 3 in this case. So we're going to go ahead and divide this up into 6. And I apologize because my division of these is not going to be perfect. But we have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. Alright, so halfway point is right here. So this is 3/6. The reason that that's significant is because 3/6 is equal to 1/2. So that's one of the huge benefits of the first step being splitting this into the fraction of the dividend, because it will allow me to multiply it as many times as I need to, having that interval in the distance that I can multiply through by. So instead of just having it 0 to 1 as just an interval of 1, I now have an interval of 1/6 units, or measures. So we will have, this is 1/6, this is 2/6, and this is 3/6. So if I were to take 1/6 and multiply it times 3, which is taking this and multiplying it by 3 times, I will reach a value of 1/2, or 3/6. So that's how we get to that value of 3/6, because when we get to 3/6, what we can do is take that and turn it into the equivalent fraction of dividing the top and bottom by 3, which is your greatest common factor between 3 and 6. So this would be 3 divided by 3 is 1, 6 divided by 3 is 2, and that's how we would get our 1/2. That's a little bit aside from the main topic here, but just to show you how the equivalent fractions are equal to each other, being 1/2 and 3/6. Okay, so the equivalent division sentence is going to be if we take the 1/6, but we, instead of multiplying by 3, we divide it by the reciprocal of 3. Because before, if we had 1/6 divided by 1/3, we said that that was equivalent to multiplying by the reciprocal of 1/3, which was 3. So now we're kind of doing the backwards way. We're saying that if we have multiplication of 3, if we divide that by the reciprocal of 3, that is equivalent. So if we have 1/6 divided by 1/3, that is equivalent to 1/6 times 3. Because we said that if 1/6 divided by the divisor is going to be equal to 1/6 divided by the times the reciprocal of the divisor. So algebraically speaking, if we have a over b, which is 1/6 in this case, divided by c over d, which is 1/3 in this case, this is going to be equal to a over b, which again is just 1/6, times 1/3, or c over d. Now, one thing I didn't mention here was this is going to be 1/6 times 3 over 1. So remember, any whole number can be represented as a fraction with a divisor of 1. Okay? So that's showing again how dividing by fractions is equal to multiplying by the reciprocal of the divisor. So this next question says, how are the dividend, divisor, and quotient represented on the number line? So the quotient, the dividend is so if we have, so the dividend is the 1/6 increment measures that if there are 6 of them, we have the whole 1 unit. So that's kind of representing this by here. These are those 1/6 increments that if there are 3 of them, which we multiplied by, then we have the resultant of our quotient. If we have the divisor is represented by the reciprocal of 1/3 being the 3 times we multiplied by 1/6 to get 1/2. Okay, so essentially we're representing the divisor here in this multiplication problem by the reciprocal of the divisor being 3. So the reciprocal of 3 is that 1/3, which is being represented by 3 being multiplied by 1/6. Okay? And then the quotient is the 3/6 or 1/2 that is resultant of taking the dividend and multiplying it by the reciprocal of the divisor 1/3, in this case multiplying by 3. Okay, so the quotient is the 3/6 or the 1/2 that we achieve when we multiplied that 1/6 times 3, giving us 3/6, giving us that quotient of 1/2. But that 3 is that reciprocal of the divisor being represented. Okay? Alright guys, I hope this helps you out. If you have any questions or need any more in-depth explanation of anything that I have talked about here, please don't hesitate to let me know. I hope this helps you out. But as always guys, thank you so much for watching, and let me know if there's anything I can help you with, and as always, take good care.